Good day. This video is a continuation of your lab guide. So it is intended to practically demonstrate certain steps that I don't find easy to explain in writing. So in your lab guide, you were required to come to OPC and to come to items under OPC. Yeah? Then you were required to connect your OPC. Okay, and in that instance a screen will pop out, screen looking like this will pop out and it says that you look here, you have fluid sim virtual controller and Codesys controller. Okay, so this is incorrectly done. Sometimes you might find it with PLC via EasyPort, sometimes you might find it with S7 PLC sim, and so you don't need to stress. Just put it on Codesys controller and process simulation in Ciros. So apparently it can control multiple softwares, Ciros and this one CoSim. I don't know this one. So for the purpose of this video, I'll just stick with Ciros. Okay, as you can see over here, we have the OPC connected, but we don't have the Codesys connected. So in this video, obviously, as I said, I want to show you the steps that are not possible to demonstrate. So first thing first, I would like you to do is to come under Codesys, go to settings, and make sure that you have version 3. The Codesys that we are utilizing is version 3. Okay, and you can just close. Now it won't close, just minimize. Okay, and you now need to go under Codesys because we are working with Codesys. So we have digital signal and we have analog signal. Yes, analog signal. So this is analog signal, so we are working with digital signal, the start-stop signals, right? Okay, so the next part is very critical. It corresponds closely with what is happening on your Codesys. Alright, so if you double click as it was stated in your lab guide or manual, you can now go to, let me just be specific. If you double click the digital inputs, and you will be able to go under digital input or mapping, then you'll be able to see the addresses for the digital inputs, and you do the same with the digital outputs. You go to digital output mapping and you just expand just like that. Okay, then I want you to do the same with the BNI that we've added. Just double click on it, all right, and go under IO link IO mapping, and then you're gonna see the process data in. These are the inputs and process data out. All right, so on the addresses now, I need to carefully explain something. Let's look here. What do we have here? We have 14i/80. So this is 14 inputs and 8 outputs. Inputs are the signals that the PLC can read, like your push button, like your sensors, and so on. Then on the output side, you have your LED lights or LED indicator, your siren, and your motors. All right, so now how are these configured? So now, since we have 14 digital inputs, you'll notice that over here we have 1 until 5 until 7 there. You have we don't utilize these main addresses, but you utilize, because you can see that say byte, You don't utilize the bytes, you utilizes the bool addresses. All right. So now you will see something that this starts at ix percent ix 0.0 until ix 0.7. I need you to consider or to focus mostly on the 0. You'll notice a certain pattern. When you move from bit 0, yeah, this they call it bit 0 here, the byte 0, you're gonna go to byte 1. So on byte 1, you have a continuation of the similar pattern whereby you are having 1.0 percent ix 1.0 until percent ix 1.5. So you can see that there's an increment. Yeah, there's an increment. So now, however, when you go to the outputs, because if we only have 8 outputs, look now, there's 1, 2, 3, 4, 5, 6, 7, 8 outputs. So that's why you don't have anything over here. So these are, they match the alignment of the inputs. You see the 0.0 and then the 0.0 here. So but what happens with the output for the one, because these are the outputs, so they are represented with a Q. So what happens with these outputs that are supposed to be here? The percent QX is 1.0. Where are they? Let's look at something. Under bit, yeah, under the BNI, this is just an extension. So if you want to add more inputs, remember, the more complex the machine, the likely it will require more inputs and outputs cards. So these are the input output link. So you can link more devices. The term they use is to plug device. So you plug a device, another BNI. So you can plug up to 4 BNIs. And these 4 BNIs, according to this computer, it uses, this is a 14 input, 14 output. So in total, you'll have 28 here of IOs multiplied by 4. You'll do the math, right? So now, you remember we were owing an output 1.0. This is the 1.0. So Codesys doesn't forget where it left off with the counting. So this is the continuation, the 1.0. However, here it's no longer matching. It has continued from 1.0 to 2. So the address here, it is skipped, as you can see. So if you come here, we have covered under the 0 and the 1. So we needed to continue for the inputs here. So we have the 2 now and 3. Then here we are a little bit behind. We have 1 and 2. So according to the training I received, it is strongly encouraged that you stick to the similar numbers. So for instance, they would encourage you, if you are on this screen, to predominantly utilize the 2 input 2 and the output 2. That's what they normally encourage because they own the similar address. So that's why they encourage. But I know sometimes you might have more inputs. In most cases, most machines or portable models, they have more inputs than the outputs. Therefore, that is the reason why. However, if you follow the addresses properly, you will never be confused. So now, how do we then correspond the addresses? Okay, so now, if say we want to utilize in most cases, it is encouraged to utilize the BNI addresses, or for the purpose of this module, we would utilize the inputs under the BNI, and we will ignore the output on the onboard. This is the onboard. Okay, so I will explain in future the onboard and the IO link master. I'll demonstrate that physically in the lab. So now the actually the inputs or the IOs on the board I prefer using the panel on them. So we connect the panel on these. So what is the panel? A panel is a controlling pane. This is where you find your inputs. So there's your panel there. So I'm gonna zoom and then put it on the side. This is your panel. It has a lot of inputs and outputs happening on it. So we have commons, we have the start buttons, we have the LEDs and stuff like that. It is best to program them on the onboard and then control assign the inputs and outputs on the machine and assign them on the IO, so it will make your life easy like that. Okay, so with that said, here I've messed up. I'll bring it again. So now, for the digital inputs, we'll utilize the what you call the panel, and then the rest of the inputs will go on the machine's inputs, machine's IOs will go on the BNI. Okay, so now let's try to do that very quickly and see how far can we go with that. So as you know, you need to go to modeling and model explorer, and you go to objects, and then distributing conveyor station, and on each PLC distributing, you just right click. So this will say PLC underscore and then the name of the machine that we've selected. So we have started the procedure afresh. We will be required to click on the OPC. As you can see, the selected controller is the OPC. We go under OPC, we go to items. This is how you expand the page so that you can see what is happening. Okay, so now these are the bits that we need to change. As you can see now, they are on virtual PLC. We don't want to use them like that, and we are predominantly going to change these inputs over here and the first few inputs on the panel, and also definitely we're going to change the outputs over here. So let's click connect. Okay, the system has connected, and as you can see, this is how it looks like. Okay, and then now we want to match the inputs. So let's start with the panel. The panel is going to be connected on the digital on the bits the bits of the digital. So that we have so this is what we're going to focus on, 1 to 7. We're going to say this is our panel. So let's go to bit 0.0. There, the E is the input, the A is output. Okay, I could be wrong, but I would like to think like that. We'll amend if we have made a mistake. E is an input, so we're going to have, so this is how you read it. In fact, this is bit 0.0, as you can see. So you consider this address there, the 0, so you know that you are dealing with 0. So as it continues, it will change. It will eventually start to change the number here. Let's see. You see now it changes to 1, and then it starts to increase to 2. So yeah, I'm correct. So this is what we're going to do. 0.0, 0.2, and 3. Let's say 4. Let's just take 4. As you can see, we have 1, 2, 3, 4. So now our push buttons are going to be controlled over here. So with the address bit 0.0, 0 0.0, 0 0.1, 0 0.2, 0 0.3, 0 0.4. This is how we are doing this. And then we don't need the thingy, what you call, we don't need the outputs there. However, we need to continue to this one, the BNI, the inputs of the BNI. We have 2 there until 7. Let's just do the 2 and the 3, the bit 2 and 3. Okay, so let's go back there. The bit 2, there's your bit 2 there, right? And then you're gonna do this, that. So you press the control key, in fact, when you're doing this, and you take the similar ones. As you can see, they are gray out, the ones that I'm taking, and I assume these are my inputs. So if you want to verify that is input, you look here, these are common. This is the A for output, these are your output. So this machine appears to be having 7 inputs, so I don't need to take more than this. I'll be taking more than I need. So let's just put these. You can just drag, and there you have changed them. Then you come to the outputs. You need to be careful. Remember what I said, that this you don't just take the output, you must follow the address, and the address needs to be correct. So the output we're going to use, for argument's sake, let's not use this. Let's not use this, the 1. Let's rather use the 2, because we can see that the amount of inputs that are required on the machine are not that plenty. There are few. There are 7. So we're going to use the outputs over here, in fact. However, you can still utilize the other outputs for 1, but I prefer utilizing these address here because they match. Remember, I once mentioned the issue of matching. So this is where I am matching. And then here we go. So these addresses have been assigned. Then we're going to apply. So this is a procedure of assigning addresses, and from here you will be able to get a signal from both the system. So let's attempt to verify what I'm trying to say. So now we're going to come here, and we need to go to online, and we need to go simulation. So once you're on simulation mode, it means that you are not required to do a lot of things. So what I'm trying to achieve here is to just test the inputs and the outputs. So let's say okay, let's wait. No warnings, you know it's a good sign. No errors, you know it's a good sign. So now press play. So we shouldn't act surprised. We know that we're dealing with these outputs here, the 2. So now on the output 0, we can change this value, and it should come and affect the Q0 over here. So to see that, let's rather come here, show monitor there. Let's monitor it, and let's expand. So you see there's one thing that we don't need. The station name we don't really need, because we can see that these are the outputs that we're trying to control. All right, so let's just press play. Look, now we're having a sign that says connecting. We're having a sign that says connecting, but let's just continue. Okay, and then I'm going to send a signal from this side, but I am sure I'm not going to get any. And one of the reasons is that I didn't amend the settings over here, and maybe that's a reason why I don't get connectivity here. So let's do it. So there's some procedures that I've made in the manual that you need to follow carefully. So let's do that. Use parent, we're gonna say enable to always here, and obviously for these two. But for the sake of this exercise, we're only gonna do these because these are ones where we've channeled, okay, or we've assigned. So now I need to plug my I/O like that, right? And let me add something. I know that sometimes it's very important. I always forget it. The symbol configuration with OPC. You see now, that's one of the problems I might have. Alright, and then even though we don't want to use any real PLC, we might still need to do the configuration. I'm going to build, and after building, you see now I need this, and I need to do changes there. This is the steps that I forgot even on my menu. It's very important. The enable direct I/O access, it's very important. It's the reason why there's no communication between the PLC and this. So from there, nothing has changed to that we have done so far. Nothing has changed. Then you connect. There's still no errors, and press play and bring this I/O. Everything's still the same. So now let's validate the communication. You see now it is connected. So yeah, there's an important step that I've skipped on my menu. I need to add it to SAP because I will have issues. So now we are on Q, this one. We are here. I don't know why. Oh, okay. Alright, say true, and then F7, then this changes to true. But I'm not getting a proper feedback out of this. Okay, but nevertheless, let's see what is happening. You have your queue running there. So my point exactly, it's correct. So you can't really see where's the queue happening from this image. You can't really see it. I can't see it as well. However, I'm going to now want to execute the Q4 I mean. So let's go to Q4. Q4, which is equivalent to Q3, we're gonna do it like this, and then F7, and then the Q3 is not working. I wanted Q4 in fact, so this one must change it back to its normal value. False. So Q4 matches because they started Q0 as well. Right, this should work. And you see this has expanded, so it means I'm now able to control. I'm now able to control my attempt something difficult. So now observe here. Focus on the magazine. I want to turn it off now. Let's see. I need to just press F7. I want to change it to false. Once it starts writing false, there's your false, and then F7, and then it goes back. So now we are sure that the communication is correct. I think I'll just edit the part that I wasted time, so that the video doesn't become long. So this is how you configure the IOs between Ciros and Codesys. Thank you for watching.